As always, my stuff I posted on YouTube, so if you're ever not here, you'll have to check back after third period, obviously, because I record during this period. Let me turn this screen. And you can watch the stuff on YouTube. Okay, so, real numbers. And you're more than welcome to write on this. It's more or less a note sheet. So, real numbers, all numbers are real numbers. Okay? All numbers are real numbers. I don't care what number it is, what type of number it looks like, if it's a decimal, if it's a fraction, if it's a pi, all numbers are real numbers, okay? And you can see that that's up here, and it kind of encompasses this whole box, okay? Within the box, there are two main types of numbers. So, my example is always heads or tails, right? So, if you have a coin, you can get heads or you get tails. There's no other options, right? It's still a coin. It's still real numbers, right? But within that, you could have heads or tails. So we got rational and irrational, okay? Now, so we got a coin, heads or tails. So you can either get heads or tails. It's point blank simple. You either have money or you have no money. You either have a phone or you have no phone. Okay, it's a straight up yes or no type thing. So, and then within rational numbers, so rational numbers are numbers that have a decimal that either repeats, okay, and I will tell you right here, most people get the irrational and the integers and the whole and the natural. It's the rational numbers that people are screwing up. So I've already taught this with my Algebra 2 kids. I've taught it last year. You need to memorize what rational numbers are. That's where everybody gets screwed up, okay? So, rational numbers are numbers that have a repeating decimal. For example, you can write the fraction... Whoa, bro. You can write the fraction 1/3. Okay, 1/3 as a decimal is really 0.333333, and it repeats on forever and ever. And it's not necessarily the decimal that makes it distinctive. It's what comes after the decimal. So after the decimal, it's the same number over and over and over and over again. That's why it's called a repeating thing. Okay, so any number in general can be written as a fraction. So far with rational numbers, we have repeating decimals and we have fractions. Now, whole numbers, for example, if you have $8, okay, or 8, you can write the number 8. In any number, you can turn it into a fraction by saying 8 over 1. So that still qualifies as a rational number, okay? And so we know that repeating decimals or fractions are rational numbers. The other type, and I didn't write it on here because it's still technically a decimal, but the best way to think about it is a terminating decimal. By terminating, I mean it stops at some finite point. For example, the best example I can think of is money. So like $1.99, okay, or $1.50. So the decimal terminates. It doesn't repeat, and it doesn't constantly keep changing. So like prices are always going to be rational numbers as long as you're talking about with change. You can't say I got $5. Okay, you still have $5, but is there any change with $5? No. Okay, so prices are always fall as rational numbers, and it's called a terminating decimal. Okay, a terminating decimal. And I'm sorry, I have not figured out how to write on here very good, but okay. Irrational numbers also have a decimal. So, for example, pi, we often know as 3.14, and I don't know the rest, but here's what I can tell you. What makes it irrational is because, not just because pi goes on for an ever and ever, okay, and a square root of 2 does too, but it's because the numbers keep changing. So it says 9, 5, 6, 7, 2, 1, 3, 4, 5, 6, 7, 8, 1, 2, 3. The number keeps going on forever and ever, yes, but the numbers are not the same after the decimal point. It goes from a 1, and then a 4, and then a 9, and then a 5, and then a 6, and a 7. It doesn't say 0.3333. So a third goes on forever and ever, but It's the same number after the decimal point. So irrational numbers do not terminate and they do not repeat. These either terminate a price, $1.99, or they repeat, okay? They keep going to the same number forever and ever. And a square root of 2 is the same way. However, if you do a square root of 2 on your calculator, okay, and for those of you guys that don't know, especially I don't know if, I have an iPhone, so I'm not sure. So if you turn your phone sideways, okay, and you push 2, and then you push, there is a square root button on here, and I'm looking upside down. Sorry, I can't see upside down. 2, and then there's a square root button. It has a square root with a little bitty 2 on the outside. And those of you guys that are online can see it too. And you push that button. You gotta type the 2 first, okay? Now, the decimal looks really, really long. It goes 4, 1, 4, 2, 1, 3. Now, it does technically terminate on your phone, but your phone can't go on forever and ever and ever. So after about 5 decimal points, you kind of know that that's not going to terminate, okay? It looks like it terminates, but it actually doesn't, okay? And the numbers keep changing. So square root of 2 is 1.1421356. It's not repeating and it's not terminating, okay? So it's an irrational number. So those are the 2 main types of numbers, rational and irrational, either heads or tails. Now, integers fall within rational numbers. That's why it's in the same box. So integers are anything with a 0, any positive, I want to say whole, but whole numbers, or any negative whole numbers. That means it can't have a decimal. So positive 100 falls within an irrational number. Negative 50 falls within an irrational number. Okay, that little indicator on the line means it keeps going forever and ever. Within integers are also whole numbers, and you can kind of see. So the 0, the 1, the 2, the 3, they all fall within whole numbers. The only difference is it's 0 and then all the positive whole numbers. It doesn't include the negatives. Okay? The natural numbers don't include 0, but they're all the positive whole numbers. Okay? So those are the 4 types. Here's what I can tell you. For example, if I say the number 3, what type of number is that? Okay, you have 2 options, either rational or irrational. But the best way is to start from the inside of the box. Okay, start with the natural. If your answer is yes, it is a natural. So if we look at positive 3, if yes, it is a natural, it's automatically a whole, and it's automatically an integer, and it's automatically a rational. So always start within the inside of that little box, okay? And constantly look at it until you get a good swing of it. So if it's a yes to the inside box, it's a yes to all the other ones. If we look at 0, the first box is a no, the second box is a yes, which makes the other 2 boxes a yes, okay? And we'll practice a little bit more with that. So if you go to your worksheet, it says what type of number? If we look at number 1, number 1 says 1/2. Is it rational, irrational, integer, whole, or natural? Okay, so we're going to look at the box and say, okay, well, 1/2, these are only whole numbers, so it doesn't fall in any of these. Is it a fraction or does the decimal terminate? Yes, so it's rational and it's only an rational number. Now, you guys know me, I'm pretty flexible, so I don't need you to write out the whole word or anything. You can just write R for rational. Okay, so we can say R, irrational, we can say IR, integer, we can say I, whole for W, and N for natural. Okay, and some of these are going to fall under multiple. Okay, look at number 2. Number 2 is 4, and here's what I'll tell you. If you went ahead and worked ahead because you feel like you got it, go back through and watch me and make sure you got it, because some people did this last week and then they had to redo the whole sheet because they did not get it like they thought they did. Okay, okay, so 4 is our another one. So number 2 says 4. Okay, start at the inside and work your way out. So positive 4. It falls within that first box. So the answer is yes. And if this one's a yes, it makes this one a yes, and it makes this one a yes, and it makes this one a yes. So yes, it is natural. So that means yes, it's going to be whole. Yes, it's going to be an integer, and yes, it's going to be a rational. Okay, and we know that it can either be rational or irrational, but definitely not both. Okay, so you're gonna have quite a few answers for this one. So yes, it's rational. Yes, it's an integer. Yes, it's a whole. And yes, it's a natural. Okay, so number 4 should look like